Now, Steamboat just erupted on May 31st at about 6:23 in the morning. There are about 1,500 to 2,500 earthquakes every year in Yellowstone, and about half of these occur as seismic swarms. This particular swarm here occurred at the intersection between the Caldera, Yellowstone Caldera's bounding faults, and the Mount Sheridan fault zone.
Hold on to your seats, folks, because the news from Yellowstone's supervolcano is sending shockwaves through the scientific community. After years of carefully monitoring, scientists have stumbled upon a bone-chilling revelation. The signs of an imminent eruption are starting to surface. What makes this discovery even more spine-tingling is the detection of a rare gas that has been locked away in the Earth's crust for billions of years, now ominously seeking out from the depths of the supervolcano. But what is this enigmatic gas, and how does it serve as a foreboding indication of Yellowstone's eruption? Join us in today's video as we delve into the mysteries of this gas and its eerie connection to the imminent threat lurking beneath Yellowstone's surface. Nestled in the rugged mountains of North America, Yellowstone National Park is a geological masterpiece, boasting a breathtakingly diverse terrain that spans across 3 states. From the iconic geysers, including the famous Old Faithful, to the multicolored hot springs and bubbling mud pots, Yellowstone is a hotbed of geothermal activity unlike anywhere else on Earth. But amidst this natural paradise lies a secret, a lurking giant that holds both awe and fear in its embrace, the Yellowstone Caldera. That's why every activity and change from Yellowstone's supervolcano is meticulously monitored, with all eyes on the lookout for any signs of an imminent eruption. The speculation and theories surrounding the volcano's activity have led to the formation of the Yellowstone Volcano Observatory, a dedicated body solely focused on studying and managing the supervolcano's affairs. And it was this very observatory that made a groundbreaking discovery, the detection of a rare gas that could indicate a looming eruption, ancient helium, a gas that hasn't been seen in a long time, and it's not a good sign. While Yellowstone National Park is known for its spectacular hot springs, fumaroles, geysers, and other hydrothermal features, it's the gases that they emit that have caught the attention of scientists. Neon, argon, carbon dioxide, steam, methane, and helium are among the gases released from the depths of the Earth. However, helium is not as abundant as the other gases in Yellowstone's caldera, and its source is intriguing. Recent research conducted by scientists from the United States Geological Survey has revealed that Yellowstone's helium emanates from deep within the rocks, where it has been stored for hundreds of millions of years before being detected. This is surprising because helium is actually the second most abundant element in the entire universe. On Earth, helium exists in 2 main forms, helium-4 and helium-3. Helium-4, with 2 protons and 2 neutrons, is the dominant form and is produced during the radioactive decay of heavy elements like uranium. On the other hand, helium-3, with 2 protons and 1 neutron, is relatively rare and has been present on Earth since the planet's formation. The ratio of helium-3 to helium-4 can vary, and scientists can use this ratio to estimate the source of the helium they come across. The presence of helium-3 in the hydrothermal systems of Yellowstone National Park is believed to be evidence that the Yellowstone hotspot originates deep within the mantle and follows a relatively direct path to the surface. This information challenges previous theories and sheds light on the complex processes happening beneath the surface of Yellowstone. However, it seems that helium-4 has a journey to the surface of Yellowstone that is more complex than anyone could have imagined. Over the course of 10 years, a team of dedicated researchers and scientists from the United States Geological Survey ventured into the depths of Yellowstone, collecting gas samples from its enigmatic regions and conducting isotopic analysis on helium, carbon dioxide, and other gases. What they discovered left them astounded. The amount of helium-4 that emanates from Yellowstone is orders of magnitude greater than what they expected to find anywhere else. But that's not all. The age of this helium is mind-boggling. Through meticulous calculations and thorough research, the scientists found that a significant portion of Yellowstone's helium-4 is likely to be hundreds of millions, if not billions of years old. This ancient helium comes from a pocket of crust that dates back to the Archean eon, over 2.5 billion years ago, containing uranium and other radioactive materials that have been slowly decaying. This accumulation of helium-4 underground is a fascinating revelation that sheds light on the geological history of Yellowstone. The scientists further hypothesized that around 2 million years ago, the Yellowstone hotspot, a geothermal anomaly responsible for the park's geothermal features, penetrated through these ancient rocks, releasing the stored helium-4 along with helium-3 from the mantle. It's a remarkable chain of events that adds another layer to our understanding of Yellowstone's geological evolution. Now, you might think that this discovery sounds intriguing for anyone fascinated by the wonders of Yellowstone, but for scientists, it comes with a sense of unease. Helium and other noble gases are crucial indicators of groundwater residence times, and the presence of helium-4 is often used to estimate the duration that water has been in contact with rocks. However, this new research challenges some of these assumptions. As it turns out, helium-4 can be unpredictable, making unexpected appearances in a system from unexpected sources, such as ancient rock pockets or magma sources. This means that previous calculations of water residence times, especially in aquifers located in volcanic areas or near earthquake faults, may be highly inaccurate due to the influence of this extra helium. It's a revelation that shakes the foundations of previously held theories and underscores the ever-evolving nature of scientific understanding. But what can helium really tell us about volcanoes? It all started with a bang when Yellowstone's earthquake struck, and people went wild with theories about animals fleeing in fear, a massive eruption looming, and helium emissions spiking in the caldera as a sign of doom. Turns out the theories were off the mark. The animals were just migrating. However, helium has more to reveal about volcano monitoring in the future, especially when it comes to examining the isotopic ratio of helium-3 and helium-4, the two naturally occurring isotopes of helium. Recent studies have looked at helium emissions in active volcanic areas, like the events leading up to the 2011 eruption at El Hierro in the Canary Islands. Researchers found that as earthquakes increased, helium emissions across the island spiked from 9 kilograms per day to over 24 kilograms per day just before the eruption, with helium ratios also rising from 2 to 3 atmospheric ratios, Ra, to over 8 Ra. This suggests that the earthquakes created fractures that allowed helium to escape, akin to a natural fracking process as magma rose and degassed under the island. However, the crustal helium signature was overwhelmed by the mantle helium signature from the magma as it neared the surface, resulting in higher helium emissions. After the eruption, helium emissions decreased with decreasing seismicity, but picked up again with the new earthquakes in the northern part of the island, indicating cracks for helium to escape, although not entirely related to new magma. Overall, helium emissions closely tracked seismicity, while helium-3 and helium-4 ratios correlated with magma movement until the eruption. Mammoth Mountain, near Long Valley in California, has been showing rising levels of helium-3 and helium-4, indicating seismic activity possibly caused by moving magma in the crust. However, Yellowstone tells a different story. A recent study published in Nature by Lowenstein and his team examined the vast amount of helium being released within and around Yellowstone Caldera and found that the helium emissions from the most active areas, such as Heart Lake Geyser Basin, are actually derived from the crust, not from the magma underneath Yellowstone. When looking closely at Yellowstone, the highest ratios of helium-3 to helium-4 are found at the heart of the caldera, with levels around 10 to 17 Ra, which is close to the composition of the assumed mantle hotspot of around 220 Ra. On the other hand, at Hartley, the base of the helium-3 and helium-4 ratios is less than 2.5 Ra, indicating a strong influence from crustal sources. Lowenstein and his team calculated that based on the uranium and thorium content, the amount of helium being released in the Yellowstone area is almost 600 times more than what would be expected from the decay of uranium and thorium. This suggests that Yellowstone is releasing helium that has been trapped in the crust for millions to billions of years, and that parts of Yellowstone sit on a crust that is over 3 billion years old. This helium release is not related to the magma underneath the caldera, but is likely caused by earthquakes and heating of the crust by magma, similar to what happened at El Hierro. This poses a challenge in using helium as a reliable indicator of volcanic activity, as the amount of helium being released may not necessarily be directly linked to magma. To better understand volcanic activity, measuring the ratio of helium isotopes is crucial. However, measuring helium-3 and helium-4 ratios in the field is currently not feasible and requires lab analysis. Merely measuring the amount of helium being released at a volcano is not enough to fully understand the situation, similar to how measuring the amount of water in a flood won't reveal the source of water, whether it's from rain or a broken water main. These studies highlight the importance of measuring helium emissions and their isotopic composition to gain insights into volcanic activity. Residents of the Yellowstone area may need to be cautious about their safety, as recent findings indicate that the Yellowstone supervolcano holds more liquid molten rock than previously estimated. This could be confirmation of an imminent eruption. The amount of liquid magma beneath a volcano provides valuable information for scientists and researchers to assess the proximity of an eruption. While advancements in monitoring volcanoes are being made, it's important to exercise caution and fully understand the complex dynamics at play before drawing conclusions. What are your thoughts on the potential for a Yellowstone eruption caused by the detection of ancient helium? Share your opinions in the comment section.